Hello. All right, we're on section 9.3. This is the last of this unit. So after we're done with this, then you will be, finishing the homework for 4.3, 9.1 through 9.3, doing the review problems, the quiz, and the test. Okay? So far what we've looked at is systems of equations. 4.3 was all about twos and twos, right? Two variables, two equations. 9.1 and 9.2 were about threes and threes. We had that extra variable of a z. And then we had, three equations. We looked at solving by substitution method. We looked at solving by matricing method in 9.2. And now we're going to keep going with our matricity idea and see what we could use this for. Okay? Now, there are certain things in mathematics that are very difficult to explain. Why we're doing it, why we do it this way, where does it come from, things like that without calculus. And the determinant of a matrix is going to be one of those things. The determinants are quite useful in normal areas of mathematics, but it's just difficult to explain. It's kind of like a logarithm. When we get to that section 2, yeah, it's the inverse of an exponential. What does that mean? Well, I can't really tell you unless we put it in calculus terms, and then we're not ready for that. So you're just going to, some things in this class you're just going to have to kind of go with. And this is going to be one of them that I'm not going to be able to really explain why we do things or what are we doing. Is just follow the directions and you will see the usefulness of it. Okay? I try not to do that, but there are areas that I'm going to have to. Okay, so we saw matrices, and now we're going to get the definition of a matrix. Okay, so this is a 2 by 2 matrix. The ones that we were working with were threes and threes, and we actually had three rows and 4 columns, and here we're going to do 2 by 2s. Okay? And what I've done here too is I have, I think it's this. Yep. Okay, so I'm on page 620 in the book. I just clicked on the textbook. And at the end of the section here, 9.3, it's got just a great summary, and it's got all of the formulas that you will need. So I'm going to keep going back and forth to this to see what we've got going on here. So you've got the concept and you've got the explanation. You can just put the page number in here if you want, or you can click over to page 620. All right. So the determinant of a 2 by 2 matrix. Okay, the definition is right here. Okay, so we say the DET is short for the determinant of the matrix A. Okay, so this is your matrix A. So the determinant of this matrix is the cross product. Okay, so we're going to take A times D, and we're going to subtract C times B. Whatever that number is, that is the determinant. So it's a special number that's going to tell us something about the characteristics of a matrix. And like I said, we'll see the usefulness of this in the back part of this section, and then if you ever do go on to calculus, you'll see more that determinants are very useful. Okay? So right now, this is what we're going to do. So I'm just going to minimize that and get back to what I've got here. All right, so I have the determinant of this matrix, so I'm going to write this down. I got a 1, 2, a 1, and a 0. We'll call this matrix A. So the determinant of A, okay, so what I'm going to do is I'm going to take and multiply this times this. Okay, so these are cross products. I'm going across. So I've got 1 times 0. And it tells me that in my directions, in my definition, I have to subtract the cross product of this. 1 times 2. Okay? Calculate it out. 1 times 0 is 0. 1 times 2 is 2. 0 minus 2 is negative 2. So this is the special number that determines this particular matrix. All right? What did we just find? Well, we'll look at it in a little bit. That's just, like I said, it's just one of those darned areas that is very difficult to grasp, it's difficult to explain, and it's difficult to understand exactly what it is that you're doing. So where's my drop down? Let's get that down just a bit so we can see it all. Okay, let's try it again. Let's say now our matrix is this. Okay, we want the determinant. The determinant of this matrix, again, we need cross products. So we're going to do -1 times -5. And then we're going to subtract this cross product. 8 times 11. No, it doesn't matter on the order of these two things. It could be 11 times 8 too. Whatever. -1 times -5 is +5. Minus 8 times 11 is 88. We can use our calculators if we feel lazy. We've got a -83 on that. Sometimes I need it, sometimes I don't. Sometimes I just like to be sure. Okay? So that's what this special number is. All right. I don't know if you can hear that. I live on a farm, and that is my cattle complaining to each other. They're usually complaining to their little. They just had some babies, and they're yelling at them because the babies are naughty, and they'll go run where they're not supposed to be, and then the mothers will scream at them. And it's no different in the cow kingdom than it is in the human kingdom. If any of you have children. All right, so now we're going to expand this. We're going to do a 3 by 3. Okay, we've got 3 rows, we've got 3 columns. So let's take a look at our, why didn't that pull up? Did I lose my, no, I didn't. I did. Huh. I have to keep going in here. When I minimized it, it actually, shoot. All right, well, here we go. I'm going to try it again. I'll try to minimize it again, but I lost it last time. Okay, so again on page 620, determinant of a 3 by 3 matrix. Yikes, look at all this. Okay, so what you want to do is you want to make sure that you're following this exactly. It's telling me I take A1, which is the blue, times the determinant of this bottom right corner. This is a 2 by 2. Then I'm going to subtract the pink, A2, multiplied by the determinant of, I'm going these two and these two. And then I add the number here, A3, and multiply that by the determinant of this upper right corner. So whatever row your the one that this lead coefficient is in here, it will not include those numbers. So you're always just using the other two. Okay? So you can write this down, you can follow it. You know, like for instance, we've got numbers in here, so these all represent those numbers. Okay? But don't go away. All right, so let's see what we got. Let's rewrite our matrix here. Matrices are used in all kinds of computer programming too. They're very useful. A lot of the linear algebra courses, if you've ever taken a higher level linear algebra, they're all about matrices too. All right, so this is my A1, my A2, and my A3. So the determinant of this, again, we're going to call this A. So the determinant of this matrix A, this is an easy one because I've got zeros right here. Okay, but I'm still going to set it up. is I take my A1 term, which is this number, and I'm multiplying by this. See how these are not in this row? So I'm always going around my number. So I'm going to put this matrice here. And then it tells me to subtract this times the matrice. See, now this is, I don't even need to set this up. It's just good practice because 0 times anything is 0. But I don't want these two, so I'm going to take this one and this one and this one and this one. Whatever row that's in, I take the other numbers. Okay? 7 and 10. And then I'm supposed to add. Again, I don't have to do it, but it's good practice. I've got a 0. And now I want the determinant of this. Okay? So now I'm going to put in okay? Now I'm going to figure out what my determinants are based on my 2x2s. So this is equal to -3 times, and here I'm going to do my cross product. This minus this. This minus this. This minus this. Okay, so here we start. 7 times 10 is 70. I'm supposed to subtract the product of this. -3 times 7 is -21. Minus 0 times, again, we're just practicing here because 0 times anything is 0. So these back two are going to be 0, so, but we need the practice. So we take the product of this, which is -20, and we subtract the product of that, which is 28. See how I'm working this out? There's my cow again. 0 times the determinant of this. We take the product of this. -2 times -3 is a +6. And I subtract the product of this, 28. All right? So you can see that these, you know, I would subtract these for -48 times 0 is 0, and so on. So this whole thing is 0, and this whole thing is 0. So really all we're dealing with is this one right in here. So I've got -3 times 70, subtracting a negative is like adding, right? -3 times, we've got what, 91 here? So we've got -3 times 91. -273. Can determinants be negative? Absolutely they can. They can be all kinds of different things. Fractional, decimal, negative, whatever. Okay? Let's try one that doesn't have those zeros in it. It's not going to be as easy. Did I go all the way up to the top here? No, I did not again. Alright, so we have the matrice A. I'm going to just rewrite it just so that I have it and I'm working with it. Okay. So what we want is we want this number, -1, times the matrice that it doesn't, it's not in that row. So that's this matrice down here. 9, 6, -2, and 9. Okay, sorry about that. I had to pause it. I don't know where I am right now. My son just came home, so just didn't want. He didn't know I was recording this lecture, so. But he just graduated. We have 4 kids, and he's my youngest. Just graduated from high school, so. All right. So anyway, now I'm going to take and subtract this number. Right? Because that's what the definition is telling me to do. So I'm subtracting a negative, and then I want to multiply it by this, 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 and this. See how those? I want to eliminate this entire row here and use those other numbers. -2 and 9, and then I want to add this number times this matrice up in here. So I've got 8. 3, -1, -2, and 9. Okay? All right. So let's start. 9 times 9 is 81. I'm going to subtract the product of 6 and a negative 2, which is negative 12. Be careful with your signs. Subtracting a negative is adding. Subtracting a negative is adding. 3. Again. 3 times 9 is 27. I'm going to be subtracting. Negative 1 times negative 2 is a positive 2. Right? Then I've got the 8. 3 times 9 is 27, minus negative 1 times negative 2 is positive 2. Why are those the same? Did I do something wrong again? Oh, I hate when I do something wrong. Yes. Shoot. Okay. I said that I wanted to do this whole matrix up here, and then I wrote this one again. All right. Like I said, look what I can do here. I've got this little eraser. Watch this. This is kind of cool. Just erase. Isn't that neat? And then I go back to my pen. And now I get my pen back. I like that. Okay. All right, so sorry about that. Okay, so there's my mistake again. I got the 9 and the 6 here. That's all right. Okay, so I take my cross product of 18 minus, and this is 9 times negative 1, which is negative 9. All right. So now I'm going to do my inside pieces. Okay, so I'm going to fill these in. Just use the calculator. This one I don't have to. This one's pretty easy. 27 minus 2. So what we're doing is we're taking an 81 and we're subtracting a negative 12. Okay, so this one's 93. And here we're taking a 18 and we're subtracting a negative 9. That was 27. And then I can just use the calculator to go straight across. Negative 1 times 93 plus 3 times 25 plus 8 times 27. I mean, obviously, you could do that, you know, longhand. I mean, we know how to multiply numbers and we know how to add numbers, but we'll just slap it in there. So we got 198. Just check that real quick just to make sure. Okay, perfect. All right, and I think, okay, so that's the first 4. So that's just work on what is a determinant, how do we use it, what would, you know, how do we calculate it out. Now, starting with number 5, we're going to see what we use it for, how it's used. Well, one of the things that we can use it for, I'm going to show you 2 different things. I'm going to show you areas of obscure shapes, and then I'm going to show you systems of linear equations, because that's what this section's in, okay? So the first thing that I'm going to show you is how to calculate out an area of a triangle that we have no information on. We don't know what the lengths of the sides are. We don't know, it's not a right triangle, so we can't use, you know, certain formulas. So what we'll do is we'll use determinants to tell us what the area is. So let me see if I can't go back. See, it keeps losing the my textbook. So, well, you can look at the textbook if you want. I'm just going to make some notes down here. The area of a triangle is equal to, okay, so this isn't any area of a triangle, the absolute value of D. Okay, where? Okay, so when I calculate out D, I'm going to take the positive value. Why am I doing that? Because an area can't be negative, right? I mean, I can't say that I have, you know, negative 100 square feet. That doesn't even make any sense. So that's why we take the absolute value. Okay? So what is D? Well, D is half of the determinant. Okay, so I'm going to multiply this by 1/2 when I'm done, or 0.5. The determinant, that looks like this: A1, B1, C1, A2, B2, C2, holy moly. And then down here, these are all 1s. Okay, so what we're doing here. What are we doing? Well, I'm going to put in my A, B, C, all sub 1 as my x coordinates of my points up there. I'm going to use my A2, B2, C2 as all my y coordinates. And then I'm going to use my determinants that I just did in problem number 4 to calculate this out. Take it in half, take the absolute value, and that just happens to be the area of this triangle. Why does it work? Again, I can't explain that. It just does. Okay? That's a really lousy way of saying it. There's not much that I'm going to do with that. I am going to do a little bit of that just because stuff, but let me move this down. All right, let me see if I can't move that down and then that like that. Okay, perfect. Perfection. All right, so what we have to do is we have to first of all get our coordinates on our points. Okay, so these are my vertices of my triangle. All right. So I'm going to do it over here and then I'm going to move it. All right. So what is this point right here, here, and here? Well, do you see how we put it on a grid system so we can see? So let's start here. This point right here is at 2, 5, right? As an ordered pair, 2, 5. This point here, that's this point, is at 9, 6. And then this point is at 7, 9. Okay? That's where we start. All right? Now I can get rid of this. Okay, so what I'm going to do is I'm going to put these in. These are all my x coordinates. I'm going to go counterclockwise, or excuse me, I'm going to go clockwise. So let's just get the matrices first. Okay? So I'm just going to randomly start at this point. All my x coordinates going clockwise. 2, 7, 9. Correct? 2, 7, 9. Then I'm going to put all my y coordinates in on this row. Again, same start. I have to start in the same spot again, and I have to go counterclockwise. Why do I keep saying counterclockwise? 5, 9, 6. 5, 9, 6. These are set at 1s. This is like your z on a 3-dimensional thing where they're set at 1. Again, I don't want to get into that right now. Okay? All right, so let's start calculating this out. So we take the first number and, okay, so that's this one, and we want to multiply by this matrix down here, this 2 by 2. We'll put that one in here, 9, 6, 1, 1. And then I want to subtract this number, multiply that by the matrix of 7, 9, 1, 1. And then I want to add this number right here and multiply that by this matrix up in here, 7, 9, 9, 6. Okay? That's my setup. So now I'm going to take the cross product. So I've got 2 times, I've got 9 and a 6. 9 minus 6, right? 9, 6. Subtract my 5 times 7, 9. I'm multiplying. 7 minus 9. I've got my 1, 42, 81. I'm multiplying. 42 minus 81. Okay? Good, 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 good. I'm going to go over here now because I'm running out of room as usual. So I've got 2 9 minus 6 is 3. Minus 5. 7 minus 9 is negative 2. Be careful with your signs. Plus 1. 42 minus 81 is negative 39. All right. Using your calculator to go straight across just as you see it. 5 times a negative 2 plus 1 times a negative 39. We get some sort of a number of 23. Okay, so that's the determinant of this thing. We're supposed to take that in half. Okay, so we're going to divide that in 2. So I'm going to take that in half. We got negative 11.5. Okay, and then I want the absolute value of that. Remember, we just take the positive value. Here's my square footage on my triangle. 11 and a half. What do we have? 11 and a half square feet. It says to type a decimal in here. It doesn't want the fractional. It wants just a decimal. So to review this, you set up your 3 by 3 matrix using your x coordinates going clockwise from some point, your y coordinates starting with the same point going clockwise. These are all ones. You figure out what your determinant of your matrix is here at negative 23. Then we take it in half. Then we take the absolute value. Okay? There's my puppy. And my cow. All right. Same thing here. You're going to label your coordinates, your vertices. You've got a coordinate system here. You're going to do it again. Okay, I'm not going to do that one. But I will do that one. What the heck? Look at my definition. Area of a triangle. It doesn't say area of a shape. It's specific to area of a triangle, isn't it? Well, what do we do here? This is definitely not a triangle. It's a four-sided figure. But let's think what we could do. What if we cut it in half? What would happen then? What happens when you cut a four-sided figure in half? Get this down just a bit. Okay, so I'm just going to quickly sketch it here. Oh, that was bad. If I cut it in half, okay, so here's my vertices. Vertices are the corners. Okay, let's make that one bigger so it kind of takes it away. What if I cut it in half this way? Isn't this a triangle? And isn't that a triangle? And if we want the area, wouldn't I just add these two areas up together? Yes, I would. So what I'd like you to do is I'd like you to separate your first triangle with your vertices and then do it again for the second one. So you're going to have to calculate this out twice. You're going to start here, put them in clockwise, your x and your y's with ones on the bottom. Then you're going to start here randomly, go clockwise with these three. Okay, so you've got your first triangle here. That's number 1. And then you've got your second triangle here. And whatever your determinant is on either, you have to do them separately and one at a time. You find your determinant, you take it in half, take the absolute value. Find your determinant, take it in half, find the absolute value. All right, add those up. That's your total area. Okay? And again, I'm not going to do it because if I do one, they're all the same. Okay, so if you need more help, if you need more direction, you go back to the one that I just did in number, whatever number that was, 5. Okay, and then 6 and 7 are exactly the same. Okay? All right, and I'll do one of these as well. 8, 9, and 10 are all the same. Okay, so here's another use of determinants and matrices. All right, so far what we've looked at in 4.3 was we solved this system. It's a 2 by 2, right? It's 2 equations, 2 unknowns. And we used the elimination method, right? You know, we would have taken a look at this and said, well, I can turn these, you know, I can turn this into a -9 by multiplying this row through by 3, and then I can add and drop and blah, blah, blah. Well, that'll work, okay? Let me show you another way that we could do it. Okay, the other way that we can do it is through determinants. Let me just get rid of that. And then I'll show you the last piece of the puzzle here. And then we'll be done. All right, so the first thing that we have to do is we have to get our formula. So here's your notes. This is all in that page 620. So the solution to a1x plus b1y is equal to c1 and a2x, and this is your generic, okay? I'll explain it in just a second. b2y equals c2. Okay, so here's your a sub 1, b sub 1, c sub 1 are the numbers. It's like the -3, the 2, and the 5. The a sub 2, 2, and 2 is your second equation, which would be the 9, the 7, and the 76. Okay, so the solution to this is, okay, obviously we have an ordered pair, x, y, and x is e over d, and y is f over d. Okay? So now we have to identify what E, F, and D are, don't we? All right, E is, by definition, the determinant of C1, C2, B1, B2. So I would take these two numbers here and put them in here, and then these two numbers here and put them in here. Calculate out the determinant, and that's E. And F is the determinant of A1, A2, C1, C2. So this is just the order that you put your determinants in, or your matrices in. And D is the determinant of A1, A2. See how we kind of get one of every combination here? B1, B2. See how that works? So what I'm going to do is I'm going to figure out my determinants first, E, F, and D, and then I can divide them, and those are my answers. So this is just the same thing that we've done, just a different way of doing it. Okay? And again, if you don't like this method, you can always use substitution or elimination method or graph them. Okay? Because those are always valid as well. All right? But I'm going to show you this way as well, so we have to see everything. All right, so let's just use these to set them up. So C1, C2 on mine, this is equation 1, equation 2, would be 5 and 76, right? And B1, B2 are these numbers right here. Those go with the y, so that's 2 and 7. And then I'm going to do this one. Okay, A1, A2. Those are my x terms, so I've got the -3 and the 9. C1, C2, those are on the other side of the equation. That's the other side of the equal sign. And then I've got A1, A2, that's the -3, 9. B1, B2 is the 2 and the 7. Now these should all be different. And they do look like they're different. That's how I knew I made a mistake on that other one. So we're multiplying here. 5 times 7 minus 2 times 76. 2 times 76, 152. Negative 3 times 76. Negative 228 minus 9 times 5. Okay. Negative 3 times 7. 2 times 9. And I'll just use my calculator for these. 35 minus 152 is 117 negative. Negative 117. And then I've got negative 228 minus 45 for negative 273. And then I've got a negative 21 minus 18. Negative 39. Okay, that's our first step. Determine your determinants. So now we're going to go back up here. E. Well, E is negative 117. D is negative 39. Okay? So we're going to take a negative 117. We're going to divide through by negative 39. We get 3. So x is 3. That's our first order pair. We're going to do it in an xy form. So we've got 3 something. Now we're going to do y. Okay, we're going to calculate out f, which is this one, negative 273, over d, which is negative 39. We got a negative 273 divided by negative 39. 7. There's my answer. A little longer, I would say, but it's just another way. Let's check it. Let's see if that works. Negative 3 times 3 plus 2 times 7 should give me 5. And 9 times 3 plus 7 times 7 should give me 76. And again, I'm going to be lazy and use my calculator. Rotten teacher I am. Negative 3 times 3 plus 2 times 7. It gives me the 5. That one works. 9 times 3 plus 7 times 7 gives me the 76. All right. So you're going to do the same, it's the same goal. You're trying to find an x and a y that work for both of those equations at the same time. It's just another way of doing it. So now you've got your fourth method. All right. Now, number 9 is exactly the same, but number 10 needs just a little bit of rearranging, okay? We have in our generic solution here, we've stacked. We've got our x's and our y's and our constants. So I'm going to want to move that 5y over, and I'm going to want to move the 7y over by adding them. So I'm not going to do this problem, I'm just going to get it set up for you. But really you want to be working with 3x plus 5y is equal to negative 7. And 9x plus 7y is equal to 19. Because in order to identify what your A1, B1, C1 are, it's got to be in this form, okay? And then you proceed from there. So that's it for Chapter 9. Chapter 9 does include Chapter 4, it's just that little piece of it, 4.3. So when I say on the quizzes and the test in my math lab, and I say Chapter 9, it does include Chapter 4. That little bit of it. So you're done with this unit. Do the review problems. Make sure you've got all your ducks in a row. Take the quiz. See what you did right. See what you did wrong. Adjust. Take the test. Okay? This has been a very short section for homework, but feel free to keep hitting similar exercise when you get those correct. Here, let me just show you something. What I mean by that. When I get one of these correct, okay, I'm done with this one, but I can always click on similar exercise and I can work with it. Now, let's say I get this one wrong, or I'm halfway through it and I have to do something and I have to leave, it'll ask me which one I want to save, and you can tell it you want to save the best score, so it won't affect your score in a negative way. Okay? But that's a great way of getting more. Here, let's just put the wrong answer in there. Sorry, that's not correct. Okay, we're going to check it 3 different times. Okay, so it says, warning, your best attempt was 100% and this attempt is 0, so we want to save the best score. Okay, and then it doesn't, see how it doesn't affect your score up there. And now I can, let's just say I had to go cook dinner, I don't know what. Now I can get another one. And I can keep doing that. So that's a great, and it keeps changing the numbers up. So that's a really great way of getting more problems. Or you can go into the textbook at the end of the sections and grab problems out of there, and then look at the very back of the book for the answers to the odds. That's another great way of getting more. So hopefully you're getting enough practice. This is probably the only unit that you're going to get this little of homework. The rest are going to be pretty heavy on the homework, and the only reason that I've really cut the homework down is because of the length of time needed for each problem. So, all right, I'm going to stop yip-yapping here and let you get at it. So, good luck.